All right, valence electrons. You've heard me talk about those before, and you probably heard of them when you were in 8th grade. Chemical compounds form because electrons are either lost, gained, or shared between atoms. The electrons that interact in this manner are those that are in the highest energy levels. The electrons that are available to be lost, gained, or shared in the formation of chemical compounds are referred to as the valence electrons. Valence electrons are often located in incompletely filled main energy levels. An example, the electron lost from the 3s sublevel of sodium to form the sodium ion is a valence electron. It's only one electron in the outermost energy level, and that's what makes it so reactive. Let's watch a visual concept.
Valence electrons are the electrons outside the outermost complete energy level. In oxygen, the first energy level, which can hold 2 electrons, is complete. The second energy level can hold 8 electrons, but oxygen only has 6. All of these are valence electrons. In this sodium atom, the first and second energy levels are full. The third energy level is not full. Sodium has only a single valence electron. Noble gases such as neon rarely react because all of their energy levels are complete. They don't have any valence electrons to participate in a reaction. The number of valence electrons for s and p block elements can be determined from the periodic table. For example, all members of the alkaline earth metals have 2 valence electrons, and all members of the nitrogen group have 5 valence electrons.
And the increase as you go across the period. So group 1 has 1 valence electron, group 2 has 2, 3, 4, 5, 6, 7, and 8, other than helium, which hydrogen has 1, helium has 2, and helium is on the noble gases because it is full, because the first energy level only holds 2. All right, electronegativity. The valence electrons hold atoms together in the chemical compounds. In many compounds, the negative charge of the valence electron has concentrated closer to one atom than the other. The electronegativity, then, is a measure of the ability of an atom in a chemical compound in order to attract the electrons from another atom in that compound. The electronegativities tend to increase across the periods and decrease or remain about the same as you go down a group. Kind of opposite of radii.
Electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons. It is measured on an arbitrary scale of 0 to 4 developed by Linus Pauling. Fluorine has the strongest ability of any element to attract electrons from other atoms. For elements in the same period, the ability to attract electrons decreases as the number of filled orbitals decreases. The hydrogen atom has only 1 electron. It is almost equally likely to attract from or give up electrons to other atoms. As atoms get larger, the distance from the outer electrons to the atomic nucleus increases. The ability of these atoms to attract electrons to their outer orbitals decreases.
Okay, so if you're looking at the one that has chlorine, sodium, phosphorus, they are in the same period. If you're looking at fluorine, chlorine, the purple line, that is in the same group, and that's group 17, or they have a -1 ionic charge. All right, let's look at a sample problem. Of the elements gallium, bromine, and calcium, which has the highest electronegativity? All right, well, let's take a look. All of the elements are in the 4th period. Notice that first of all. Bromine has the highest atomic number and is the furthest to the right of the period. So bromine then should have the highest electronegativity because electronegativity increases as you go across the period. And that concludes our Chapter 5. Thank you, and remember, study for the test. It's posted on Mr. Higley's website. Thank you.